All right, so this is part 2 of explaining this level manager for bubble sort. So void start. So this is called right when the script becomes active, when this level loads up. Set app state, current state. So that's why I was able to, as you saw, I was able to switch that public enum. And when I clicked play, it jumped to that part of the experience because I'm calling this with whatever the current state is right at the beginning. So set app state. So private method called from public method. It's internal. It's just for the class to call. And it's expected to receive in something of type bubble sort state, which is an enumeration I created. And I'm calling it temp state. So whatever gets passed into it, it'll set our current state to that. So yes, in this situation, that's redundant. But it's going to get called from other parts of the script or what have you. So I'm setting the current state right through the inspector, and what's the first thing that when we pass it in, we set current state. So basically, it's setting that variable to that value that it already is. So it doesn't do anything in this situation. But down the road, when other scripts call it, as we'll see, it's important to keep track of the current state. So I just do a debug statement. I want to know, this could probably go at this point. I'm pretty much done with the testing, but I use this to see, make sure what's being passed in. Is this the state we're going to that I expected? So if you go into the console, if you look through here, intro, this is one of the names, introduction to the next button. So now for each listener object in our list of listeners, we're going to go and tell them set the listener state. So now this list, if you remember, it's an empty list. It doesn't contain anything. We just declared it and said we are going to have a list of objects of type listener that we're going to call listeners. And it's empty. But all these other scripts that are inheriting from listener, they go out and on awake, which is called at the beginning of the Unity scene, they go out to level, which is bubble sort level, dot register listener. This is a reference to this object. So if you noticed, bubble sort table is a listener, container manager's listener, the tray is a listener, the UI controls are listener, the buttons are listeners, right? So when they send out a reference, it'll be of them as a listener, which all of them have access to these methods. They must declare them. So the reason that they're virtual means that they're empty methods. They just have a signature, a name, a return type, whatever input parameters are to be expected, and you declare it as a method with these, but you don't put anything in, they're empty. Now, whoever inherits from them must declare what this method does. And that just means if you're not going to use it, they can just remain empty. But if I move through here, so for example, SetListenerState, this is the table. Look at all the things that it does when we set the listener state. And we'll go through a switch statement, but just note SetListenerState does a bunch of crap, right? Container manager. There's a lot of stuff here because setting up these containers is like one of the big parts of this. Swap, move, set listener state. Here it is. All right, it receives some type of bubble sort state enumeration, and it figures out what it needs to do to itself based on that. So long story short, all these classes that inherited from listener did something with this method because we said you must. It's a virtual method. It's empty, but anyone who inherits from it will do something to it. Will fill out their own functionality for it. So, but all these classes that inherited from listener, all their objects call this register me. Basically, register this listener with a reference to myself, the listener. So register listener. So this method sits on the level manager and it passes in references or objects of type listener. And what does it do? It adds this new listener to our list. So list listeners dot add whatever this new listener is. So now we have all these references to these live active objects in our scene, which inherit from listener, which means they're listening to the manager. Whenever the manager says, we're going to update the state, I want you to do this, I want you to do that, it sends these method calls out, and those who wish to do something with that information will do something. So all the listeners register themselves, which means they just get added to this list. So this list grows dynamically. It says, so the manager is aware of everybody who's supposed to know something. So that's why on start, and to be just a quick note, that's why this is on awake and this is on start. So awake gets called before start. So every loop, if there's anything that needs to be awoken, that gets called first. Then if there's any start methods that need to be called, that's next. There's a whole bunch of other methods, but eventually update gets called. So if anything is awoken on a current cycle of the app, their stuff will run. If anything needs to be started, that'll be run, and then update, what have you. So that's why since it's in awake, I know that this will be called before this because it's in the start, which gets followed next. Because I don't want to run this on an empty list. I want to know everyone. I want everyone to register, and then I want to notify them. So I can set this from the inspector. This gets called at the beginning. And the core of it really is this. So for each listener object that we added to our list of listeners, go call it SetListenerState method with this new state, this new bubble sort state enumeration. So there's different looping mechanisms. There's for each, while, do while. You'll be most familiar with fors and for each. So fors, you have to write a little bit more information. You need to put more details in. A for each makes things a lot easier. So if you have enumeration collections such as lists, you can just say for each, basically element in the list, in the container, I want to do something. So for every object we have registered in our list of objects, listener objects, go call their SetListenerState. And if you look, they all have that defined. All right, and I'll move through this. So just be aware that all the listener objects call this RegisterListener, which basically just added them to a list. Whenever we change the state of our app, based on our list of enumerations, we go tell them this method, SetListenerState. So notice that there's some other methods here. The button was pushed, do some stuff, a very long list. The task was successful. The task was not successful. We wish to populate containers. We wish to depopulate containers. We wish to set the app for different situations, and later on we'll talk about why this was needed, but just these are being called basically on we're going to wait a little bit. There was some timing issues. So if you notice later on this massive switch statement up here, there's some invokes, which I'll cover what's happening here. But I'm just going through the structure of bubble sort level. All right, and notice some of these are familiar. Populate container, task unsuccessful, depopulate container. And notice that those that sound very familiar to listener methods, look at what all they're doing. It's just cycling through for each listener objects in our list of listeners, go call the same method name. So go tell the listeners that the task was unsuccessful, you need to give them a hint. it's time to populate some containers based on which state of which part of the task we're in. It's time to depopulate some containers. And for task successful, not only are we telling everyone that the task was successful, but then we go through and we figure out what's the next step of the enumeration, what's the next state we should move to in our experience. All right, so I'm not going to move through the each of these scripts in the same way. I'm not going to just go through all the scripts and then explain everything and then move through it. At this point, I think the easiest solution the easiest way to move through all this code is to just move through the level manager as it calls different states on their level, because it is the manager of the whole level. And so as it's called, we'll trickle down through the other scripts and see what they're doing to see how the whole level is setting itself based on the state it should be in. And so that means set app state for each listener. We should really start here, and we should really move through all the listeners. So the inspector is set to the very first in our enumeration, which is introduction to next button. I have to tell them and teach them everything about the app to use the app, which starts with the next button. So we're going to move through all the listeners and see what they're doing to set up the initial state when I click play, and it looks like this. These buttons move out, they turn invalid, or they turn gray, this turns empty, these turn empty, this populates with text, that populates with text, and after a little bit, this button starts blinking, and we're waiting. So notice all these messages, we registered all these listeners, and then we turned off button next, and we actually moved into this enumeration. And then based on moving into this state, the table set itself to this state. We turned off the button swap. We turned off the next button. The tray set itself to whatever it should be in this state. The container manager did the same. So that's why I have these debug statements kicking out. We see basically the listeners are stating, yes, we received the message and we did whatever it is that you said we should do. So, and we're waiting. We're just waiting for the user to do something. There's nothing to do yet. But once the user pushes that button, the button sends a response. So basically what we do is the bubble sort level is like the most macro feature aspect of this experience. And we have a bunch of middle managers. The table manager, the container manager, the tray manager, they're all middle level managers. They just listen and set up states. It's actually the micro interactions which have this strange power dynamic. We're actually waiting. They're actually the ones in control at this point. Everything's been set by the macro manager with the middle level managers listening to them. And the micro managers, if you could call them that, the buttons, are just being responded to commands from their middle manager. And we wait. We're in this cycle where there's no user input. And the only thing that can change any of this at this point right now is this blinking next button. And if I come down here, the next button has these colliders on it, just like I was explaining the web camera and how it's working with colliders to figure out what the user is doing. We have these colliders on the buttons that respond to the hand, and the buttons move up and down a little bit. And only when the buttons move down so far, based on this script, the up and the down position, will it execute this script. So I'm going to just gloss over a lot of details, yada, yada, yada. And what's really important is on trigger enter, on trigger stay. Here, on trigger stay, if the button is below its down position, meaning the user has pressed the button far enough down where I can consider this button to have been pushed, not only does it set itself but the most important thing here, it tells the level manager that a button was pushed and it sends in its game object name, which was like button next. All right, and since it's a listener, if I move up here, it registered itself with level manager. And since it's a micro interaction, it takes all of its commands from the middle. So notice there's no like set state on it because it gets called. So it's state like reset the button, should it be blinking? Everything is called from its manager, like the middle manager. I think it's the UI controls. But it has all the control of the experience right now because it's waiting for the user to push it far enough down for us to consider that button pushed. We could tell level manager that a button was pushed, and this was the game object that pushed it. So button pushed, the name of the button. So we switch on the current state, and if we're in a certain state that we are looking for the next button, in which case we're in this one right now, introduction to the next button. So if the button was pushed, and this is our current state, then this is the case that will evaluate to true of the entire switch, and we'll execute the code here. And all we're doing is, if the button name is button next, which it's the only button that's active, so this technically can never be false, but we're just putting in safety checks, then yes, the user pressed the next button when I told them in the tutorial that you need to press the next button. I'm training you to use the next button. And that's the case, we're going to set the app state to the next one, which is introduction to the swap button. So if you go to the states here, we must teach the user about the next button, then we must teach the user about the swap button, and then so on. These are the most basic elements that they must do before we can teach them more. So what happens here is the button was pushed, we set the app state to introduction to app state, and that's why set app state, the first thing we do is we update current state, because this temp state comes in, we update this variable, which is keeping track of our current state, and then we go out to everybody else, all the listeners, and we say, hey, the next button has been, we are in a new state now, and it's going to be introduction to swap state. That's the temp state, and we can look through the listener objects and see what happens. And that's actually the main loop, the main cycle of this experience. The level manager, the enumeration of the level manager that is saying which state are we in, gets changed. And more often than not, it's going to be this next button doing it, but it's some type of micro interaction, some type of real interaction that the user is doing. That enumeration changes. The level manager goes out and does what it needs to do and then tells everyone else that the state has changed, and they all do what they need to do. And we're going to look at that, how the table changes, how the tray changes, how the container manager changes. And so the level manager sets up the pins, and the user, through the micro interaction, knocks the pins down. And then the level manager sets the pins up, and then we wait for the micro interaction for the user to knock the pins down. And then the level manager sets the pins up through the middle managers, and then the user knocks the pins down. And bit by bit, little micro steps, we move through the level. And right now, we're having to be moving through the tutorial. So the level manager set the pins up. The middle managers did all the detail work. And then the user has a micro interaction. And then we move on to the next step. And that's it. It's just interactive experiences, and they're very, very core. They're elements that you use to build them are not sophisticated. It's just like programming. It's the explosive nature of the processing power of how much you can do. So it's just one little, as you're coding up these little features. It's just the devil's in the details. You're trying to make a cohesive experience by setting all these middle managers to do stuff. And you wait for the user to interact, and the level manager gets aware. So the flow of information, the level manager tells all the middle managers tells the micro interactions what's going on, and then something happens, and then we wait for the user. The user is only interacting with the micro interactions, and the micro interactions go back until the highest level. They cycle back. It's like the lowest. It's like the lowest of the low is the only one that can talk to the king. The information flows down, and somebody has to tell the top of the hierarchy when the user interacts, because the user is usually interacting with the micro interactions, the smallest elements. And it's the smallest elements that tell the highest manager what has just happened. So usually the information is supposed to flow one way, and usually it flows top to bottom, but it needs to cycle back at some point. So it's the micro interactions, what the user is interacting with, that connect back to the highest manager, the level manager. So you want to keep your flow of information in your code as simple as possible, because you get very complicated, and keeping those nests straight is your most important tool, as a programmer and as a designer of these experiences. So this video has gone far enough, and we're going to take another step into the code at this point here. So we're going to look at the middle managers next.